My name is Peter Bunyard. I work with Dr. Plamen Nechev and two others from the University of Sergio Arboleda, which is in Bogota, Colombia. And in particular, we are looking at a phenomenon which is found in the equatorial tropics, which in fact is the barometric tidal wave. And here you see the barometric tidal wave averaged over 45 days, and we have done a simulation using trigonometric transformations to follow the actual curve that you get from the barometric wave. And in making the simulation, we basically derive coefficients which can be related to the passage of the sun over the Earth during the course of 24 hours, so from night to day. And also we are in particular interested in the relationship between humidity, evapotranspiration as brought about through the rainforest, and its impact on the barometric curve. And we find that a component of the trigonometric transformation, in particular the cosine component, relates extremely well to changes in humidity that you get diurnally between nighttime and daytime in the rainforest of the equatorial tropics. In this case, from Costa Rica, from a biological station called La Selva. We are particularly interested in how this evapotranspiration transforms into a vertical upward force, which will in fact take the air column up and of course therefore provide a suction for the local surface, which will draw in the local winds and therefore bring moisture into the system and add to the amount of moisture in the air column. And it is the condensation of that water vapor in the air column which gives rise to what we call the biotic suction force or mechanism. And here we have evaluations derived, in fact, from the trigonometric transformation, looking at the column of air in the lower atmosphere. This is the troposphere here, where we have, of course, a temperature inversion with a high temperature at the surface and a cold temperature there, which at the tropopause then moves into an increase in temperature with altitude. So we have altitude here and we have temperature along here. And we've looked in particular at this portion of the temperature curve going from absolute zero up until beyond 300 degrees Kelvin. And well, this graph here at the base is derived from the liquid water level path over the Pacific Ocean. And you see that it follows, over 24 hours, it follows this kind of concave curve here. And when we apply this curve to the cosine component of the barometric tidal wave, we get extremely good correlation. All of this is suggesting, in conclusion, that the evapotranspiration taking place over the tropical humid rainforest is giving rise to a vertically directed force, which therefore sucks in the local winds, which leads in fact to a force which will have an effect on what we call the trade winds, which come from Africa all the way to the Amazon basin. Thank you.